Okay, so it's calculators at the ready for this section. I've tried to pick out 4 exam questions that will make these 4 hopefully a little bit clearer to see rather than just showing you the formula. So first up, perform calculations involving mass, number of moles, and MR. So we're going to be using moles equals mass over MR there. Right, so calculate the maximum mass of calcium chloride, this stuff, that can be produced by reacting 8.02 grams of calcium across here with an excess of hydrochloric acid. So I don't need to worry about that, got as much as I need. But I've got 8.02 grams of calcium there. Right, so the first thing I can do, if I know the mass of calcium and I'm given the relative atomic mass, then what I can do is moles equals mass over atomic mass in this case, 8.02 divided by 40.1, and that comes out at fifth, 0.2 moles. And then what it's wanting us to do is to look at how much of this we can produce. Now, ratio, 1-to-1 ratio. So for every one of these, I will produce one of them. So 0.2 chloride produced. And calculate the maximum mass. So I need to rearrange this equation because I need mass to be the subject. So mass equals moles times MR in this case, since we're looking at a molecule here, or relative formula mass, if you want to use that. So then 0.2 times 111.1, and that gives me 22.22 grams in there. So that's the first bit, just being able to use this equation here. And if need be, you can remember it like that, but you should be able to rearrange a 3 variable. Next one, calculations involving the concentration, the molarity. So this is where we've got N equals CV coming into it. So student dissolves 16.6 grams of potassium iodide, Ki, makes up a solution of 500 cubic centimeters. Calculate the molar concentration of the solution produced. Right, so first off, I would get my equation C equals N over V. I need to rearrange this to make concentration the subject. So I can see what I need to know. I'm given the volume in the question, but I need to convert that. So 500 divided by 1000. Now moles. Moles I can't see anywhere. But what I do have is I've got mass and I've got the relative formula mass. I can use this equation we were just looking at up there. Mass, molecular mass. So moles equals 16.6 grams divided by 166, 0.1 there for moles. So now 0.1 divided by 0.5 in there. So again, if you get your calculators out, and we get a concentration of 0.2 moles per decimeter cubed. Right. So moving down, next one, be able to perform calculations involving concentration in grams per decimeter cubed. So here, calculate the concentration gram per decimeter cubed when 1 mole of NaCl dissolved in water. Now, the easiest way to do this is just to work out the concentration in moles per decimeter cubed first. So we know N equals CV, V equals N over V. So 1, see there, got volume. Done 500 divided by 1,000. That gives me 2 moles per decimeter cubed. Now, since I'm looking for a unit in grams per decimeter cubed, I can see the volume hasn't changed. What I need to do is I need to change moles to mass. Now, to change moles to mass, all I do, moles times MR. So if I've got the concentration in moles per decimeter cubed, I'm just going to multiply it by the MR of NaCl. So 23 plus 35.5. So 2 times 58.5. So 117 grams per decimeter cubed there. And then the final bit, be able to determine whether a reactant is a limiting reagent or in excess. Right, so what we're trying to look at is, from our two chemicals here, which is going to run out first? So the easiest way to do this is we want to work out the number of moles of each. Right, so the hydrochloric acid is a solution. So I know N equals CV. Concentration there, 1. And then times by, just to convert to dm cubed. So that's going to be 1.5. So 1 times 1.5, 1.5 moles. And I'm going to do the same now with calcium carbonate. So I've got 100 grams, 100.1 grams of calcium carbonate. Now it's a solid, so I need to use moles equals mass over mR. Mass, 100.1. And the mR, CaCO3. So we've got 40.1 plus 12 plus 16 times 3. 16, 32, 48, 50, 60, 100.1. They've made that nice for us. That's obviously going to equal 1. Now, don't straight away just compare these. What we need to do is look at the ratio first. So for every 1 calcium carbonate, it will neutralize 2 hydrochloric acids. So if I've got 1 mole of this, that means it can take out 2 HCl's. So I've got less than 2 hydrochloric acid moles. So it means this is going to run out first. So therefore, that is in excess. You can think about it the other way. 1.5 moles of this, you could do 2 to 1. So for every 2 of those, it will neutralize 1 of them. So if I had 10, it would take out 5. If I had 20, it would take out 10. If I've got 1.5, it would take out 0.75. And if I look here, I've got more than 0.75. So all of that would have been fully used up, and there would still be 0.25 of that remaining. Okay.